Hello, in this video, I'm going to derive the formula for centripetal acceleration, v squared over r. Let's have an object moving along a circular arc of radius r. It underwent angular displacement of theta, and let's call the velocity at this and this position v1 and v2. Let's draw a vector triangle involving v1 and v2. Now, what does this side of the triangle represent? It represents the change in velocity, delta v. See, the original velocity plus the change in velocity is equal to the final velocity. Do you see that this angle here is actually the same angle theta here? See, r and r forms the angle theta. So v1 and v2 should also form the angle theta because v1 and v2 are just these two r's turned 90 degrees. Let's draw another triangle based on r and r. Of course, this angle here would be theta. So what should the third side of this triangle correspond to? Now look here. The arc length, this arc length, should be exactly equals to v delta t. So delta t is the amount of time taken for the object to go from here to here. And v is just the speed. No? V is the same as v1 is the same as v2 because this guy is going at a constant speed. So the arc length is v delta t. If theta is very small, then the arc length is practically the same length as the line joining these two positions. Get it? The curvy arc length and the straight line joining these 2 points are practically the same if theta is small enough. So the third side of the triangle here is basically equals to the arc length, which is v delta t. So some students are going to say, hey, are we cheating? Because the two lengths are not exactly the same, right? Not true, because we're trying to work out the instantaneous acceleration. So the angular displacement is really very, very small. And when the angle is very, very small, the two lengths are really practically the same. For example, you go to the swimming pool, you look at the water surface. Is it a straight line? Yeah, it looks straight, but you know that it can't be a straight line because the earth is round. So that straight line that you thought was a straight line is actually part of an arc. So we are really making a very valid approximation here. Now back to the two triangles. Do you realize that these two are similar triangles? Because they are both isosceles triangles, subtended by the same angle theta. What can we do with similar triangles? We can equate the ratio of the corresponding sides, right? So we can write delta t over v is v1 or v2, but they are the same, so we just call it v. So delta v divided by v1 should be equals to the ratio of the corresponding sides on the other triangle, which is v delta t divided by r. Rearrange the equation, you get delta v over delta t is equals to v squared over r. When delta t is small enough, delta v over delta t is actually the instantaneous acceleration, which is v squared over r. So with some simple geometry, we have shown that when an object is doing circular motion at a constant speed v, radius r, then its velocity is changing at the rate of v squared over r. That's all. Ta-ta!